ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Good morning. Now today's concept is oxidation and reduction. So let us see with the old definition. So what is oxidation? Oxidation is a process which involves addition of oxygen or removal of hydrogen or both. What is oxidation? Oxidation is a process which involves addition of oxygen. That means you have to add oxygen. So compare the reactants and products. If the number of oxygen atoms increases, then we can call it as oxidation. What is the next one? Removal of hydrogen. Compare the reactants and products. If number of hydrogen atoms decreases, then we can call it as oxidation, or it can involve both. So oxidation is a process which involves addition of oxygen or removal of hydrogen or both. Let us see some examples. Fe to FeO. Let us consider this change, this chemical process. Fe is converted to FeO. So what is the difference? Here there is no oxygen, here you can see oxygen. That means the process involves addition of oxygen. Therefore we can call it as oxidation. Or let us take one example. This is ethyl alcohol. So it is converted to acetaldehyde, CH3CHO. Count the number of carbons 1, 2. Here you have 2 carbons, forget about it. Oxygens 1, 1, same number of oxygens. Hydrogens 3 plus 2, 5. 5 plus 1, 6. You have 6 hydrogens here. 3 plus 1, 4. So 6 hydrogens here. Here you have 4 hydrogens. That means hydrogen atoms are removed. Therefore you can consider it as oxidation, removal of hydrogens. Next. Ethyl alcohol again is converted into, say, acetic acid, CH3COOH. Number of carbons here, oxygens, 1 oxygen you have, here 2 oxygens, so number of oxygens increased. Hydrogens 3 plus 2, 5 plus 1, 6 hydrogens here you have 4 hydrogens, so hydrogens are removed. So the process involves both, there is addition of oxygen as well as removal of hydrogen. So this is the basic definition with respect to oxidation. Let us see the next one, that is reduction. Reduction is a process which involves addition of hydrogen or removal of oxygen or both. Addition of hydrogen, removal of oxygen or both. So let us study some examples. First example, say ZNO is converted into Zn. Zinc you have say oxygen is lost, you have removed oxygen, removal of oxygen, therefore it is reduction. Removal of oxygen. Next example. Let us take C2H4. Let us take C2H4. C2H6. Conversion of C2H4 to C2H6. See the number of hydrogens. Here you have 4 hydrogens. Here you have 6 hydrogens. Right? That means that 2 hydrogens have added. 2 hydrogen atoms are added. Therefore, addition of hydrogen. Let us take one more example. CH3COOH gives CH3CH2OH. 2 oxygen atoms are present in the reactant, 1 oxygen atom is present, so number of oxygen atoms are decreasing. 4 hydrogen atoms are present, here you have 6 hydrogen atoms, 2 hydrogen atoms are increased, that means 2 hydrogen atoms are added. So, removal of oxygen as well as addition of hydrogen, so both are involved. So, this is the old definition with respect to oxidation and reduction. Now, let us see the limitation of this old definition. This definition can be applicable for those processes which involve oxygen or hydrogen, right. So, we can apply only for those chemical processes which involves oxygen and hydrogen. We cannot apply this definition if oxygen and hydrogen are not involved. What is the meaning of that? Let us see some examples to understand this. Suppose if I take this example, Fe is converted into FeCl2, right. I cannot explain, I cannot classify this reaction into oxidation or reduction based upon the old definition, because there is no oxygen, there is no hydrogen. Now, coming to this process, this chemical change where ethylene is converted into glycol. Here number of oxygen atoms are increasing, at the same time number of hydrogen atoms are also increasing. Still we are not able to classify based upon the old definition, right. So, it has some limitation, it is not applicable if oxygen and hydrogens are not involved, and we cannot explain this particular example where the number of oxygens are increasing as well as number of hydrogens are also increasing, right. The old definition is modified. The old definition is modified by replacing oxygen atom with more electronegative atom. So, in the place of oxygen they have added more electronegative atom. In the place of hydrogen, less electronegative atom or electropositive atom. A more electropositive atom. So, what is the meaning of this? Oxidation is nothing but addition of oxygen, or you can say that addition of more electronegative atom. Removal of hydrogen or removal of electropositive atom. Coming to reduction. Reduction means addition of hydrogen, nothing but addition of electropositive atom, or removal of oxygen, nothing but removal of more electronegative atom. So, instead of oxygen use electronegative atom, instead of hydrogen you can use electropositive atom. So, here if I come back to here, Fe is converted to FeCl2. So, chlorine we are adding, chlorine is more electronegative than iron. So, addition of more electronegative atom we call it as oxidation. OH, OH is more electronegative atom. Addition of more electronegative atom is nothing but oxidation. Now, you can classify them into oxidation because more electronegative atom is added. So, that is the change proposed to the old definition. Instead of oxygen, replace it with electronegative atom. Instead of hydrogen, replace it with electropositive atom. Next, modern concepts. So, in terms of electrons, you can define different ways in terms of electrons. So, what is oxidation and what is reduction in terms of electrons? Oxidation is a process which involves removal of electrons, loss of electrons, removal of electrons. We call that process as oxidation. So, you can guess for reduction. Reduction is a process which involves addition of electrons, or simply we say gain of electrons. Gain of electrons, we can call it as reduction. So, with respect to electron, this is the definition. Oxidation is defined as a process which involves loss of electron. Reduction is a process which involves gain of electrons. So, let us see some examples. Zn is converted into Zn plus 2, right. 2Cl minus gives Cl2 plus 2 electrons, that is 2 electrons. Mn plus 7 plus 5 electrons. Mn plus 2. Right. Now see here. Zinc is converted into Zn plus 2. Right. So we are removing 2 electrons. So removal of electrons or loss of electrons, we call it as oxidation. This process is oxidation. Right. Come back to this. 2Cl minus converted to Cl2 plus 2 electrons. So Cl minus is converted to Cl2. In that process, it is losing 2 electrons. So loss of electron. The process involves loss of electrons. Therefore, we can classify this reaction as oxidation. Mn plus 7 is converted into Mn plus 2. In that process, Mn plus 7 gains 5 electrons. So, Mn plus 7 gains 5 electrons and converts into Mn plus 2. So, gain of electron, we call it as reduction. Gain of electrons, we call it as reduction. Come back to this. Cu plus 2 electrons gives Cu. Cu plus 2 is converted into Cu by gain of 2 electrons. So, gain of 2 electrons is nothing but reduction. So, this process is reduction. So, this is the definition with respect to electrons. Next, in terms of oxidation state. Oxidation is defined as a process in which the oxidation state of an atom increases. If the oxidation state of an atom increases, then the process we call it as oxidation. If the oxidation state of an atom decreases, then the process we call it as reduction. So, oxidation is a process in which the oxidation state of an atom increases. So, increase in oxidation state, increase in oxidation state. Reduction. Reduction is a process in which the oxidation state of atom decreases. Decrease in oxidation state. But how do you calculate oxidation state? How do you calculate oxidation state? What is this oxidation state, or oxidation number. So what is this oxidation state or oxidation number? Right. Oxidation state of any atom or element in a molecule or ion is an arbitrary charge assigned to it based upon certain well defined rules. So it is nothing but a charge assigned to the atom present in a molecule or ion based upon certain well defined rules. Based upon rules, certain well defined rules, it is the charge given to the atom or element in a molecule or ion. So oxidation state or number is nothing but arbitrary charge given to that atom based upon certain rules. So what are these rules? So oxidation, okay, in short I will write here. Arbitrary charge assigned or given to atom in a compound, in a molecule or ion on the basis of certain well defined rules. Well defined rules. So only 2 points to right. So let us see the rules. Rules to determine the oxidation state. Right. Now, here we have to consider two cases, right? Two identical atoms, two different atoms. Right. If the bonded atoms are identical, that means same. If the bonded atoms are identical, then the shared electron pairs must be distributed equally between them. Right. Let us say one example. I am taking two atoms A. Say this atom gives one electron, another atom also gives one electron. These are the shared electrons between two atoms. If bonded atoms are identical, then the shared electrons are equally distributed. Equally distributed means E electron దీనికి ఇచ్చేయాలి, దీని electron దీనికి ఇచ్చేయాలి. That is the point. Second point, if the bonded atoms are not identical, let us take one example here. I am taking A and I am taking B. Say A gives one electron to form the bond, B gives one electron to form the bond. And let us assume they are not identical, therefore their electronegativity will not be same. Let us assuming B is more electronegative, En electronegative than A. Atom B is more electronegative than atom A. In that case, the bonded electrons, both the electrons, they are assigned to, both these electrons they are assigned to B. So try to understand the difference. So what we are doing is, we get this oxidation state by redistribution of bonded electrons to more electronegative atom. Why we are equally distributing? Because there is no electronegativity difference. Both are identical, same. Therefore, their electronegativity will be same. Therefore, we have to equally share. But if you have unidentical or if you have two different atoms, then the shared electrons are given to more electronegative atom. After redistribution of the shared electrons, right, then you have to find the net charge developed on the atom. After redistribution of electrons, the net charge developed on the atom will give the oxidation state of that atom. So, it is simply in simple language, we are distributing the bonded electrons to more electronegative atom. After this, the net charge developed on the atom will give the oxidation state. If you have identical atoms, then they will have same electronegativity, then the shared electrons are equally distributed. Otherwise, they are redistributed to more electronegative atom. So, let us see some examples. So, what is rule 1? Rule 1 is, in case of identical atoms, if two atoms are identical, then the bonded electrons are equally shared. Rule 2, if the bonded atoms are different, then the shared electrons are given to more electronegative atom. Third rule, right, after redistribution of shared electrons, the charge developed on each atom will be the oxidation state. So, let us see some examples. HCl, let us start with HCl. The bond between hydrogen and chlorine. So, before going further, let us see how we are studying how to find the net charge. I will explain few examples. So, before going to further, first write the atomic number. What is the atomic number of hydrogen? 1. What does it mean? It contains, it indicates that there is one proton and one electron. So, it contains how many protons? One proton. What is the atomic number of chlorine? 17. That means it contains 17 protons. A neutral chlorine atom possesses 17 protons and 17 electrons. So, 17 protons. 17 protons means 17 positive charges. Then electrons except shared electrons. Electrons other than shared electrons. See here, in this bond formation, hydrogen gives its one electron, chlorine gives its one electron. This is the electron of hydrogen, this is the electron of chlorine. How many electrons does hydrogen atom possess? 1. And that one electron is participating in bonding. Does it possess any other electrons? Answer is no, because it contains only one electron and that is participating in bonding. So, electrons other than shared electrons, the answer is 0. It does not possess any electrons. You have to write in this column. Next, leave this space here. Electrons except shared electrons. It contains a neutral chlorine atom contains 17 protons, that means it should contain 17 electrons. Out of these 17 electrons, one is participated in bonding. So, it contains 16 electrons. It contains 16 electrons. Next, shared electrons. How many electrons are shared between two atoms? How many? One electron of hydrogen, one electron of chlorine. So, 2 electrons are shared between them. 2 electrons are shared between them. Then, you have to redistribute the shared electrons based upon electronegativity. Based upon electronegativity. redistribution of shared electrons. These two electrons should be redistributed. Now, based upon electronegativity, which is more electronegative first? Are they identical atoms? No. Hydrogen, chlorine, they are not identical. Chlorine is more electronegative than hydrogen. So, these two electrons should be given or assigned to more electronegative atom. We have to assume that we are assigning, we are giving this to more electronegative atom. So, how many electrons will be assigned to hydrogen? 0, because it is less electronegative. These two electrons are given to chlorine. You have to assume that the two electrons are gained by chlorine. Right. Next, net charge developed. Right. Hydrogen contains one proton. How many electrons it has? 0 plus 0, 0. It does not have any electrons in this molecule. Its share is 0. It contains only one proton. One proton means what is the charge? Plus 1. Coming to this. Count the total number of chlorine. 16 plus 2, 18 electrons, right. So, 18 electrons, 17 protons. That means it contains one electron excess. Therefore, its oxidation state should be -1. So, what I can write now? Oxidation state of hydrogen in HCl equal to +1. Oxidation state of chlorine in HCl is -1. So, let us take one more example. Okay, we can use this. So, I am taking Cl2, right. Atomic number 17, that means it contains 17 protons, it also contains 17 protons. So, one electron of chlorine here, one more electron of this chlorine. So, electrons except shared electrons, out of 17 electrons one is participating. So, it contains how many electrons? 16. Electrons except shared electrons, how many? 16. So, here also it will be same, that is 16, that is understood. Next, shared electrons, we have to write in the middle. Shared electrons, how many electrons are shared between them? 2 electrons, 1 electron of each chlorine, right. Next, redistribution of these shared electrons. Right, come back to that chlorine. Are they identical? Yes. What happens if they are identical? Their electronegativity is same. So, none of them will lose or gain electrons. That means you have to assign 1 electron each. So, redistribution of shared electrons. Out of these 2 electrons, its share is 1 and the other chlorine atom will get 1 more electron. Next, net charge. It contains 16 plus 1, 17 electrons, 17 unit negative charge. How many protons? 17. 17 electrons, 17 proton, net charge will be 0. How many electrons this chlorine has? 16 plus 1, 17. 17 unit negative charge, 17 units positive charge. Therefore, its oxidation state is 0. Therefore, oxidation state of chlorine in Cl2 is 0. So, we can do some more examples. Let us take a little complex molecule. So let us take carbon dioxide. Right. So I will write the number of protons. Oxygen atomic number 8, that means it contains 8 protons and 8 electrons. So 8 protons, 8 positive charge. Carbon 6 protons, 6 positive charge, 8 protons, 8 positive charge. Electrons except shared electrons. 8 protons means how many electrons it contains? 8. Out of 8, how many electrons are participating in bonding? 1, 2. Out of 8, 2 are participated in bonding. So left over will be 6 electrons. Coming to this carbon. Carbon has 6 protons. Atomic number is 6 protons, 6 electrons. Out of the 6 electrons, how many are participating in bonding? 1, 2 with this oxygen. 1, 2 with this oxygen. Total 1, 2, 3, 4. So out of 6 electrons, 4 are participating in bonding. So out of 6, if 4 are removed, left over will be 2 electrons. 2 electrons. Electrons other than shared electrons. Coming to this oxygen, 8 protons, 8 electrons. Out of this 8, 2 are participating in bonding. So apart from these 2, how many it contains? Still 6 electrons. Right. Next, shared electrons. How many electrons are shared between them? Between these two, 1, 2, 3, 4. So you will get 4 electrons. How many electrons are shared between these two? 1, 2, 3, 4. So here you will get 4. Redistribution of shared electrons. You have to redistribute these 4 electrons based upon electronegativity. Carbon, oxygen, which is more electronegative? Answer is oxygen. Oxygen is more electronegative than carbon. Therefore, these 4 electrons must be given to more electronegative atom, oxygen. So I am assigning these 4 electrons here. Right. So it will get 0 contribution. Here also these 4 electrons are given to oxygen. The contribution from this bonding is also 0. Redistribution of shared electrons based upon electronegativity. Oxygen is more electronegative than carbon because oxygen belongs to 6th group, whereas carbon belongs to 4th group. If you move from left to right in a period, electronegativity increases. So how many electrons are there? 6 plus 4, 10. How many protons? 8. 8 positive charge, 10 negative charge. So what I will get? Minus 2. 8 minus 10. Coming to this, 6 protons, that means 6 positive charge. How many electrons? 2 plus 0 plus 0? 2 minus 2. 6 minus 2, what I will get? Plus 4. 6 minus 2 plus 4. 6 protons, 6 positive charge. So 2 electrons minus 2. Electrons are negatively charged, so minus 2. 6 minus 2 gives plus 1. So here also same. 6 plus 4, 10 electrons. So minus 10. 8 protons plus 8. What I will get? Minus 2. So what is the oxidation state of oxygen? So the oxidation state of oxygen in carbon dioxide is plus 4. Example is hydrogen peroxide. Hydrogen peroxide. So this is the bonding H O O H. So hydrogen atomic number is 1, therefore it 1 proton, 8 protons, 1 proton. Electrons except shared electrons. So it contains only 1 electron and that electron is shared here. So it does not contain any other electrons apart from that 1. Out of 8 electrons, 8 protons, 8 electrons. Out of 8 electrons, it uses 1 electron here, another electron here. That means 2 electrons are participating in bonding. Apart from this, it contains how many electrons? 6 electrons. So here also same story, 6 electrons, here 1 and here 1. Hydrogen 0. Shared electrons, how many electrons are shared between these two? 1, 2, 2 electrons are shared. Here also 2 electrons, here also you will get 2 electrons. We have to redistribute them based upon electronegativity. We know that oxygen is more electronegative, so the 2 electrons are given to this oxygen. Here you will get 0 for hydrogen. Coming to this bond, 2 electrons between 2 oxygens, identical, same electronegativity, therefore equally distributed. So from these 2 electrons, one will be given to this oxygen, one will be given to this oxygen. Out of these 2, one you have to write here, one you have to write here. Between the oxygen and hydrogen, oxygen will gain 2 electrons, hydrogen will get 0 electrons. So count 0 electrons, 1 proton, so plus 1, 6, 7, 8, 9. 9 electrons, 8 protons, therefore minus 1. 6, 7, 8, 9. 9 electrons, 8 protons, minus 1. 0 electrons, therefore you will get plus 1. So in hydrogen peroxide, the oxidation state, H2O2, we call it as hydrogen peroxide. So the oxidation state of hydrogen in hydrogen peroxide is plus 1. Oxidation state of oxygen is minus 1. This is sulfuric acid H2SO4. The redistribution of electron can be made easily. You can easily do this by assuming a covalent bond to be ionic. But you have to assume that a covalent bond is ionic and assign the shared electrons to more electronegative atom. How many electrons you are assigning it, you have to just count it. Based upon that, you have to calculate the charge. Let us see how. We are assuming the covalent bond to be ionic and redistributing the bonded electrons. Let us start with this HO bond. So between these 2 electrons are shared, one is oxygen and other is hydrogen. Which is more electronegative? Obviously oxygen is more electronegative. So assign one oxygen electron. If it gains, if I give this electron, since it belongs to oxygen, no change. But if I assign this hydrogen electron, right, assuming that this is ionic, this electron is gained by oxygen. The hydrogen electron is gained by oxygen. Since oxygen is gaining one electron, it will get minus 1 charge. Because of this, it will get minus 1. Coming to this, here oxygen gives 1 electron, sulfur gives 1 more electron. Between oxygen and sulfur, which is more electronegative? Oxygen. Oxygen, next you will get sulfur. So down the group electronegativity decreases. So oxygen is more electronegative. So it gains the sulfur electrons. So from these 2 bonds, this oxygen gains hydrogen electron as well as sulfur. Since it is gaining 2 electrons, its oxidation state will be minus 2. This hydrogen is losing its electron, its own electron. Loss of 1 electron will result in plus 1 charge. Right. Coming to this oxygen. So here it has to 1, 2, 1, 2. So 4 electrons are shared between them. 2 electrons of oxygen, 2 electrons of sulfur. Already we have studied that oxygen is more electronegative than sulfur. So sulfur loses its 2 electron share. Therefore oxygen gains 2 electrons. Therefore its oxidation state must be -2. Here also same story, -2. Coming to this oxygen, it is exactly same. So it will be -2 plus 1. What about sulfur? Sulfur is bonded to oxygens, right? 1, 2, 3, 4, 5, 6. 6 electrons. It uses 6 electrons to bond with 4 oxygens. Oxygens are more electronegative, therefore it uses how many electrons? 1, 2, 3, 4, 5, 6. It is losing 6 electrons, therefore oxidation state should be +6. So the redistribution can be made easily by assuming covalent bond to be ionic and finding the net charge developed on it.